Slides. G'day. Welcome everyone to the PASS DevOps virtual group. I'm Hamish Watson. I'm hoping that you can see me in a couple of ways. And to my left is my good friend, Rob Sewell.
Hello, everybody.
This month, we've been very, very lucky to be broadcasting from Microsoft headquarters in Redmond. Both Rob and I are here as part of the MVP Summit. And today, we're going to be doing some lightning talks on DevOps. And to my right, I have Grant Fritchey, the PASS president. Thank you so much, Grant, for coming along. We have René, who is one of the leaders of the Global DevOps Bootcamp. We have Vicky. I'm just basically saying people's first names because you all introduce yourselves. Program manager, part of the data platform group. And Terry. Yeah, done. And Mathias, also one of the leaders of the Global DevOps Bootcamp. And Richard, an RD, Regional Director. And Geert, also one of the leaders of the Global DevOps Bootcamp.
Rik, stand up.
And down the back, Rik.
And some audience.
And we were lucky enough this year to have some audience. Thank you so much for turning up. So, as mentioned, today is going to be lightning talks, and first up, we're going to have René. So I'm going to hand over to René. Cheers.
No, you're going to have to click.
Oh, okay. Hello, everybody. My name is René. I have this great thing of a 75-minute presentation in 5 to 7 minutes. So I'm going to rush. My talk is about the shift to rugged DevOps, which is more a conceptual talk about how important it is to have security within your pipelines. So let's get this started. Oh. Is this actually going off the time that I have? Because then I have to do my presentation in 4 minutes. 2 minutes. Oh man, that is challenging.
Click. You guys saw that, right? Click.
I was already on slide 3, but now I have to start over.
We are presented. We have control. Why are we not sharing? Share. Must have been the flipping between.
Okay, so let's go back. Uh-oh, no, this. What have you done to my machine? Okay, so I will just try this again. The shift to rugged DevOps. Yeah, okay. So this talk is a 75-minute talk, but it all started with my journey into a compliant world of a bank, where I got this whole freaking list of things that I need to control in terms of rules that I had to comply to when I was implementing a secure pipeline, because that was the question that was asked by the product owner in question. He said, build me a secure pipeline. So because I didn't know what a secure pipeline was and what he actually meant, I asked him, what is a secure pipeline? And he provided me this big Excel list with all kinds of controls that didn't make sense in a DevOps world. So not to give up directly, I started walking through this list, and an impression of my day is that I became very, very sad. Well, I became a bit desperate, into rebellious, into no, I'm not actually going to do this stuff because I cannot even understand what it's saying. And if it's impossible to understand, it's impossible to implement. If it's impossible to implement, you cannot validate the stuff. And if it's impossible to validate, you cannot even maintain the stuff. So I went back to the compliance officer, or actually the security officer, and I said, why are you doing this? Can you explain to me why you are doing this? Because I can follow all these compliance rules, I can check all the boxes, but that doesn't make you secure. So he said, well, okay, that you made a point here, and well, we are trying. And why is it important? I said, well, why isn't it important? We have all these hacks, we have Maersk, cyber attacks everywhere. So we really need to take another approach into compliancy and especially security. So we need to move from a compliant world to a rugged world. And what does that mean? Compliant is checking the boxes. Do we comply? But security is a state of time. I am secure at this moment in time. But secure at this moment doesn't make me secure in the future, because something happens, a patch is not applied, some new breach comes, a new vulnerability comes, and we have to be resilient in this new kind of world. So we need to move towards rugged DevOps, and that is what this talk is all about. And it was all inspired by this guy from former NSA director Michael Hayden, who said we need to shift our mindset from preventing breach, where we do everything to prevent things from coming in, to assuming breach. So we have to do the things, but we also need to make sure that when they do come in, and they will, that we can actually be resilient to all the changes that will happen. One of the major things that I would think is important towards this shift of rugged DevOps is that we need to go into the mindset of you build it, you run it. So teams need to be responsible for building the software, but also running the software. And that with running the software comes a big responsibility, because if you have that responsibility of being beeped out of your bed in the middle of the night, you are more incentivized to actually do something about the software you actually write. So when we look at a compliant pipeline, whatever that may be, we can divide that secure pipeline into 5 stages, which is the coding phase, where we actually build the code, the storing phase, where we push the code into source control, and from source control we will start a build to actually make an immutable package out of the code that we actually committed to Git. Then after that, we are going to deploy it, and then after that, we are going to release it. And I deliberately separated those two because it's not the same thing. Deployment is the technical approach. We are moving the bits towards the server, where release is something like flipping a feature flag, where you expose the functionality to your customer. If you have that kind of functionality within your software, you are really resilient to things, because you can hide stuff, you can easily apply stuff without disrupting the whole service. So some no-brainers that you can do if you are talking about secure pipelines: we have to shift left. We have to bring security into the teams. We have to have that expertise into our teams to actually make it work. One of the other things that we see a lot, we see credentials flying around on the networks. We see credentials flying in repos. Do a search on GitHub for password or something, and you find a lot of things. And there are tools for that. So for example, Microsoft has this credential scanning tool. There are Talisman, that's an open source credential scanning tool that you can just easily plug into your pipeline to scan for all these secrets that are easily exposed and easily leaked. Also, the packages that we are used, software that we use is not only from us. We use 80% of software that is built by other people. And that software, do we know that software? So use package scanners like WhiteSource or Sneak or Veracode or Black Duck to actually scan your packages. Does they contain vulnerabilities, or do they contain licenses that we don't want to have in our organization? For example, GPL licenses. We don't want to make our software open source. And we can use things like in the Azure DevOps, like release gates and testing all over the place. So very, very fast. We also need to assume trouble. So preventing stuff is what we are good at, but we also need to make sure that we assume trouble. What happens if it's already in production and things happen? There comes detecting the stuff, like monitoring, baselines, alerts. How can we see something happens? How can we respond to stuff? What is our MTTR, mean time to recovery? We need to have continuous delivery, need not only to deploy new features, but also to deploy our patches and our bug fixes. And after that, we need to recover in a nice way. So we have to write our postmortems, we have to share our experiences in the organization, and we need to have everything as code. So baselines and everything as code, that is what Geert will talk about in the Azure Security as code. And it's a very good example of how we can use things as code into our pipelines to actually make it work. And if we do focus on the right things, make things secure, we will see that we will eventually become compliant in an automatic fashion. So that was it. I don't know if I'm on time. I think more or less. My name is René. Thanks. Move the word to Geert.
How do I present? Just Thank you very, very much, René. That was stupendous. 75-minute talk in 5 minutes. We're impressed. We're impressed. He said he could do the challenge, and he did. Yep, you should be sharing it.
Connected to go to webinar is what I say.
So if you minimize this. Where's the minimize button? Excellent question. Yeah, that's what they can see.
I can see.
See my browser now? Yeah, that's fine.
Can you hear?
I'll just put this on. Maybe change the camera. So yeah.
Yeah, you can see your camera.
I will share the camera as well. Yeah.
Yes, please.
It's turning on. Yeah. Okay.
Go.
Okay. Go. So continuing with René's story, I'll actually introduce myself first. My name is Geert van der Cruijsen. I'm a colleague of René, also from the Netherlands, working as a DevOps consultant. And well, I ran into a lot of the same problems as René did. And well, we had some discussions actually last MVP Summit. That's where this happened. And when we were back on the airport, we started, well, how can we solve this? How can we move it to a more to a world where everything is stored in code? So we brainstormed a bit. So how can we go set some baselines of how your Azure environment is actually secured, and then move to a world where all our changes are automatically audited and those kinds of things, because we just use Git for all the changes. So what we started doing is building this open source project called Azure Security as Code. And what it actually does is it gives us the ability to scan the Azure environment, create YAML files out of it with all the configuration settings for different types of resources. If you go to this GitHub pages, you can see what we currently support, and well, it's still a work in progress thing, so it's far from complete, but it already has a lot of features that are really useful. So what you could start with now is we can look for resource groups and which users or group have access to these resource groups. We can give you an overview of SQL Azure databases, and actually not only the control plane, but go into the data plane of the SQL database and see which accounts have access to these databases. So, well, basically what I want to share with you is a quick demo of how this tool would work in practice in your own Azure environment. So what I'm going to do is, well, first show you all the commands we have. Basically, we have a lot of commands, and they're split up into two areas. We have a get asec command with all the different resources, and we have a process asec command with the different resources. And the difference is the get command is actually to create a baseline, so we can store all the baseline in our Git repository. And then we use the process command to, when we do changes in Git, we can create a build pipeline that processes these changes back into the actual environment. And this way we can have an automated audit trail, etc., with all the Git goodness we know and love. So what I'm going to do now is I'll show you my Azure portal. What I did is I created a resource group called asec demo resource group, and there's a few things in here. Like there's a database in here, and there's a key vault in here. And what I'll show you is I'll go to identity and access management. I'll show you the different roles. So there's actually a team 2 here that has contributor rights. So what we're going to do now is we'll execute this command, get asec resource group, and it will create a a baseline for us. So what it will do, it will run, and in this resource group directory, it will actually start creating a YAML file. And if you look at this YAML file, what it does is it will look at this resource group and it will list out all the different permissions that we set specifically on this resource group. So we have this team 1 and team 2 that are assigned to this resource group, and we want to make team 2 a owner. So we'll just edit this file. And what we could do now is, well, normally now I'll do it from the command line, but normally you would create like a pull request. Someone else could review these permission settings, and then we would have a automatic build pipeline that would execute this process command. What this will do, so we'll execute this, the process command. It will see, well, I did not have team 2 in a role of owner, so I'll add that to Azure. So when we go and refresh this page, was it done already? Actually have to go to the owner role. Here it's actually added, and it should be deleted from contributors as well. I think it's being delayed now, but this way we can just have all our changes in the Azure environment stored in our Git repository. So that was the first thing we created, and what we're going to do now is actually move on to this from like the control plane of Azure with resource groups and those kinds of things into actual resources. So what we have as well is we have this command to get our SQL Server, and I'll execute that as well. Since we only have a short time, 1 minute. Okay, then I have to really be quickly. Then we'll get 2 YAML files here as well, and you will get a basic information about your server. So what we could do here is we can add firewalls in here, for example. You could do that in the portal, but then you don't have any audit trail of who did that, when he did it, why he did it. And if we do this in code, then we can store it in our pull request. We can say why we did it, etc. So it works exactly the same. We get the stuff, we do changes, and we process it again. Then we have another thing here that's actually pulling in the database. And what it does is within the database, it can actually show all the SQL users that are in the database. It can connect it to a key vault name and key vault secret to actually store the login stuff for these users, and we can assign roles. So what we could do is actually add another user to this database by just adding this. What we did is I had a key vault. It has a secret for actually doing the connection. We can store this back in Git, do the process command, and it would actually update our database, and that's it. So with that, I would like to finish up, and I would really invite you to give this library a try and yeah, give us feedback. That's it. Thank you.
Excellent. Hamish, can you move the presenter over to Mathias? Yes. Oh, there I am. Excellent. Thank you very much, buddy. That was absolutely awesome. Another brilliant lightning talk demonstration. And now over to you, sir.
That's awesome.
All right.
Is that a big scary
Yeah.
Let's see how this goes. I think we're okay. Let's see. Am I good like that?
Good.
All right. So I'm Mathias, and I wanted to continue on the story around DevOps and automation, and I'd like to share some stuff we've been doing to integrate database work into the DevOps process. So the first thing I wanted to just say is, what is database DevOps to me? Well, it's a matter of integrating the whole database development thing into development, release orchestration, and operation. And it means that the teams are responsible for doing end-to-end work. And we want to make sure that this is not an isolated thing, but this is everyone's business. And the final part is that we also want to make sure that this is part of the everything as code story. Right? So just want to show a quick example today on how we could possibly do that. And one approach a number of teams I've been working with are doing is that they use entity framework migrations to get the model-first development approach, get everything in version control, and then also get automated schema generation. And then together with Azure pipelines, we get a system for automating things. We can do binary promotion, so we build once and we deploy changes in a controlled fashion. So we also get traceability governance and all that good stuff. Right, so yeah, I'll try to do a 5-minute demo of how this thing could work. So essentially, I want to make some database changes, code first, create the database migration, make sure we handle all of this as code, and then build, deploy, and update some environments, right? 5 minutes. Okay, so what I have here, see if I can get this one out of the way, can I? I got a small program, and this is just one of the basic samples. So I have a very small data model or an entity model. So this is the entities my application use, the blog and a post. And underneath this, obviously I got some code. So if I wanted to extend this program to store blog information in the database, and I want to do this code first, then my idea is that I just go and add a new property. Let's do something really simple. And the idea of this incredible change is that I will introduce a name field in the database as part of my data model.
First or last?
So this is definitely code first.
First name or last name?
Yeah. If we have had more time, we could do some interesting work. But, all right, so I've added the code to do this, but this is far from being something that's part of the database. So if I want to use entity framework, I would, for instance, go to the console, and then I can run a command that will generate the schema definition for me, or should I say the migration that is needed to make a change to a database so that a name field gets added. And so I'll add a migration, and I'll call this one adding name field very creatively. And of course, this the environment has a tendency to not set focus on the right project. So I have to be in the folder where I have my .NET Core application in this case. So I'm running the code, running the entity framework tool, and hopefully it goes smoothly. It says done. And what happens now is that in my project, it has now added a magic file that contains the C# code that represents adding a column to the database. All right, so what I then want to do is to get this into my environment. And what I have right now is I have a database, and in this database, I've got a table with where I've run this deployment before. So I have the blog ID and the URL. So to get my code into the database, I obviously need to get this into a pipeline. So the pipeline would consist of checking in code into a Git repository and then have it build and publish the result. So I'll go here and I will just use Visual Studio to commit this. So, and that commits it locally to my Git repository, and then I will sync this up to the server. I will push it up to the Azure repo. And what happens now was that I got a conflict. That's an interesting thing with Git. So apparently I made some other changes. So I will just pull down the changes from the remote and then integrate that. And fingers crossed everything works as planned. And so all I'm doing now is dev work, trying to integrate things and get it into the repository. That seems to have worked. So what happens now is that this code got pushed to Azure DevOps. And in this repository, I also have a magic file called Azure Pipelines.yaml. So this is my infrastructure or my pipeline as code. And this component here will run a tool that will generate a SQL script for me. So this is where the magic actually happens, that from the code I checked in, I actually will get the migration SQL statement that I can run on my database. And I'll set up a build and deployment pipeline. So this should have been triggered now when I checked in the code, and it's running. It's running. So what happens now, hopefully, is that the code gets compiled and it runs all the steps, including the entity framework migration part. And as part of this, it produces a number of artifacts. One of those is a migration file. And if I go and look into the content of this artifact, I've just gotten a file here that I can open up. So this one has been generated by the CI system or the build. And if everything goes as planned, I could open up that file. Now that has disappeared, but eventually it runs. Ah, crap. All right. But the good part here is that in the end, we got SQL generated, and it also does this in an idempotent way, so I can run this script many, many times. And now, since I'm over time, just want to check that I also had a pipeline running, and now hopefully this has run in the dev stage. It does some magic things, and if I go and refresh the blog table here, I might even see that the new table has been added. And you know, 7 minutes go really, really fast, but there you go. So this is magic database as code.
Thank you.
Thank you very, very much, Matthias. That was absolutely brilliant and under pressure as well. So now we've done databases. Now we're going to go really, really shiny with you.
Cool. Right. Okay, I'm going to start my 7-minute timer. Hi, everybody. Okay, so I tried to condense a 50-minute talk into 7 minutes, and I did that by attempting to throw away all of my slides. So we're going to try and do this a bit in whiteboard, and then hopefully a little bit in DevOps. So what we're going to look at is how sort of DevOps works for machine learning, because for a lot of machine learning tasks, it looks and feels a bit like software, but you'll quickly see that it's not. So for anybody who's never looked at machine learning before, let's have a look at a bit of our process. So we start off with some data, and then typically what we're going to look to do is we're going to look to split that data. This is called a supervised learning. Maybe 70% of our data is going to go in to be trained with, and 30% of our data is going to go off to be tested with. Now I pick some kind of algorithm, and now if that was trying to predict something numerical, I might go for some kind of regression. If I was trying to classify something, so maybe I've got a straight line doing a regression, or some kind of decision tree where my data's running through it. So I take this algorithm, and all I'm doing really is I'm taking my data and this algorithm, and I'm tweaking a whole load of parameters so hopefully I outpop a model. And now with this model, I'm going to take that other 30% of my data, push my model off, and then I'm going to validate whether or not it was good. So I'm going to just basically, for a regression, I'm going to draw out my line, maybe it's a linear regression, and I'm going to look how close to that line my data was, and I'm going to draw little lines between them, and I'm going to work out what my loss is and work out if that's a good model or not. And let's say it's a great model. I'm really happy with it. As a data scientist, I'm really good. I'm happy. This is typically where I stop. And now this is where things start to break down, right? Because this is where our data scientists stop. But as DevOps people, we want to get this stuff into production. So there's this horrible statistic around that about 85% of all data projects fail. And they fail because, well, a lot of data scientists and a lot of data people typically don't have the right skills to actually get stuff in production. So our face turns a little bit angry. So what do we want to do if we want to actually get this model into production? Well, we need to do a few more things to it. So we really need to take that model and we need to give it some way that somebody can start using it. So we might wrap a REST API around that. So now somebody can start calling that with a REST API. But I mean, that's not it. So what we then need to do is we need to think about, well, how do we handle dependencies? How do we get this to be scalable? If I give it to the business and they start liking it and then they start putting it out to all of our customers, we need this thing to scale. So a great way to do that is to take this model and then put it inside a Docker container. So we put our model, we put our code in there, we put our model in there, and then what we need to do is we need some way to actually get that out. So in Azure, that maybe we take that image and we push that off into a container registry. So we take that version here and we call it maybe version 1 of our model. And as things change, maybe we build up additional versions of that. And then ultimately, we need some way that we're going to attempt to deploy this. So maybe we look at using something like Kubernetes. So now if we look back through this around what things we have and what things we need to deploy. Okay, so we've got some data. If we want to reproduce this model, if we want to reproduce how this works, we need to try and version this data. Don't version data inside Git. It will just kill you. So don't do that. We need to version this logic here, how we trained. If we've put a random seed in here, we need to know what the seed was. We need to know what algorithm we used. We need to version our model. We need to version our code that we did, our REST API. We need to version the Docker image. We need to version what we inherited from. We've got versioning here. We've got versioning in our YAML. And that's a huge amount of work for somebody to maintain. And that's a huge amount of work that you cannot expect a data scientist to have to understand. So we need to work together. But we can simplify this and we can make it very easy for our data scientists to deploy this sort of stuff. So if you look at this sort of basic flow here, we've got our data scientist, and what they're going to be responsible for is just committing code to source control. They're going to commit some code, and we're going to trigger an Azure DevOps pipeline. So they're going to commit they're going to do a Git pull their data down. They're going to commit their stuff, and then we're going to have Azure DevOps do the rest of this stuff for us. So do a Docker compose, build out our Docker image for us, tag it, get it all ready so it can go up into a container registry, push that into a container registry, get it running on Kubernetes, and then service back an endpoint that somebody can actually go to. So I won't try and run it live, but we can very quickly have a look at what those sort of steps might look like. Zoom in a little bit. And we can go from something that seems quite complicated and an awful lot of things that somebody has to do. So all of these little blue boxes, we can go to a pipeline process that seems quite simple to understand. So we commit some code, we point it in the right place, we build that image, we can push that image, we can clear down Kubernetes and we can redeploy Kubernetes, and we can get everything running so that there is a nice pipeline that gets deployed into Azure automatically for us. And now this stuff takes a lot to get running, but if you can get it running, it can really accelerate your DevOps teams, whatever your data science teams, and they can really start sort of guaranteeing that return on investment that a lot of data science teams are really suffering with. And yeah, so that's it. That's all I sort of wanted to go through, a real high speed through a bit of data science and a bit of data ops. And yeah, so thanks very much. So the details are there. Thank you.
That was so very cool, Terry. Thank you very much. So it's going to be a short delay whilst
It's on you now.
whilst the
ALM
ALM
guys
guys
is running out, and we're going to pass it over to.
How's that look? And can you hear me okay?
I can hear you just fine in here.
All right. The question is, does anybody else hear me? Sounds like the software's happy with it. Excited to be here. This is a fun thing to do. I wanted to talk about a different aspect of DevOps, which is, I think, something that people are really challenged with. We're usually pretty good at communicating within our own team, but we're good at communicating across teams. And so I wanted to run down a few of the tactics for communicating across teams fairly effectively, starting with method. There's a lot of different ways that we communicate, and we can start simply with just Messenger. And different messaging strategies, this is a fairly narrow pipe. You can only communicate so fast, so far. Long messages aren't well sent that way, and most of the time people are pretty unhappy with that. And if it's not working well for you, then the trick is to change the medium. Generally, we have good intent when we communicate, we're just not actually communicating well. So if we wanted to move up to a little better method, maybe email. Now, the email, you can write a longer message. The problem is that there's a negative cascade that happens there. Messages get longer and longer and longer. The perfect email is one that's only a few seconds long. And just maybe, my perfect response to any email is okay. But if it's getting longer than that, well, then you're probably going the wrong direction. You should change the medium again. And in that case, you could try telephone. But, nobody really uses a telephone anymore. And there's a reason why. The previous two methods, messaging and email, they were asynchronous. I could send a message anytime, I could respond anytime later. You don't have to wait for me, you don't have to interrupt me. Telephone doesn't have any of those features. It demands attention, it is interrupting, and then it's also synchronous. You don't have time to wait or time to think. None of those things work. And better still, if the telephone's not working for you, is the meeting. So getting it face-to-face with someone. There's really no substitute for that. That's how humans were built. We see each other's expressions, we can see each other's intent much more effectively when we're together. But there is a higher level of communication than that. If you're willing to move beyond, move to pizza. Pizza is the ultimate form of human communication, especially amongst technical people. And I don't really care what pizza you have. If you prefer a vegetarian pizza, do a vegetarian pizza. You like eggs on pizza? Well, I don't understand you, but you can have eggs on pizza. The one thing we know for sure, pineapple is not acceptable. Actually, that's not true. You do you. You like pizza, you do the way you want it. It turns out tech people like pizza. More importantly, there is an aspect of humanity that is hardwired to trust people we break bread with. And so if you really want to communicate with large groups of people, bring food into the equation. Don't waste a good lunch. An opportunity to eat with someone and to understand them better, that raises the level of trust. And all successful communications actually involves a great deal of trust. So anything you can do to improve that trust is something you want to work closely with. Now, there's a power to a one-on-one meeting, and especially over lunch. If you're trying to influence someone, you're trying to reach into a different team, that's a great place to start. But larger group meetings are useful also. And so having everyone eat together, you probably do this with your team. The question is, do you do it with other teams? And this whole DevOps process is about spanning all of the teams, all of the different people that ultimately affect the success we have with software. So having those opportunities to grow trust across those teams really comes down to spending time together in settings that tend to engender more trust. And that's why I usually introduce food into the equation, and pizza just happens to be an easy form of that. If you want to get a little more formal with this, think about something like a lunch and learn. Now, these were typically team-only activities that your team would get together around a technology that your team cared about, and maybe there's some pizza involved, and you watch a video or interact in some way and have a discussion around the lunch and learn. I would say most importantly with lunch and learns is enough time to talk, because the real reason you're doing this is to communicate. And so the more time you have to talk, the better. Smaller stories, smaller videos, smaller classes serve the purpose better. If all we have time to do is to watch a video and then we have to run back to work, we've missed the opportunity. But here's an idea when you go across teams. What if we invite another team to present to us? So a classic scenario for this would be a development team presenting to operations and DBAs how they actually build a feature. Walking through how they gather requirements, break it down into user stories, code it into it, break it out into issues and code them together, test it and actually get it ready for deployment. Try the same thing with our operations folks, looking at a deployment or understanding a network attack. Or on the database side, what is our disaster recovery strategy? How do we recover data? What are the methods we understand for doing performance tuning? The biggest thing I want of those cross-team lunch and learns more than anything is for each team to understand that the other team's job is hard. That moment where they can look across the table and say, hey, wow, what you do is tough. That's a good moment because that engenders a level of trust and respect in the work that allows us then to collaborate around other issues. That same method of presentation, where we take an example, we take a diagram, we walk someone through a process, it tends to put all the humans on the same side of the table. I like bug reporting that way too. A bug report is another kind of lunch and learn. And the less that individuals have to generate those reports, the better off we are. If you can actually take the automated report and put it up on the screen and we all sit together across those teams, look at that report saying, where did this come from and why do we have this problem and how can we get past it? Well, then we tend to be on the same side of the problem. And that's another strengthened form of communication across the teams. Maybe I'm a little bit out of time, but I talk fast. I hope that got you some ideas on how to communicate. If you want to talk further, that's my Twitter handle. Thanks so much for listening.
Such a smooth, amazing voice. Thank you, Richard. So, right. Yes. Yes, I am. I'm on the microphone. We've had a quick microphone.
We had a little technical upgrade.
Hello, everyone.
No, make it DevOps. Yep.
Oh.
There you
Did I break it?
Awesome. All right. How much time? An hour, right?
You have exactly 5 minutes.
Damn.
Starting now.
So I'm going to go different, right? A lot of the talks so far have been very technical, and DevOps is very technology focused. I mean, it has to be, because you've got to automate things. If you're going to do DevOps, if you're going to move into an automated mechanism, if you're going to work with the development teams, with the DBAs, with the SAN administrators, everyone is involved with DevOps. Everyone. If you're going to be doing this stuff, the key here is that you've got to automate. So you're going to get into tooling, but that's not what I want to talk about. I don't want to talk about tools. What I really want to talk about is communication. I'm not following up on Richard. That was a great talk, by the way, and excellent stuff. The key here for me, for DevOps, if you're really going to implement DevOps, you have to change your company culture. That's number one. You cannot simply assign DevOps to Peggy, and now you're doing DevOps, right? That's not how it works, right? Peggy is DevOps. We're done. Cool. Mission accomplished. Not at all. You've got to, absolutely got to, change the culture of your organization. The culture of the organization has to reflect the concept of DevOps. The culture of the organization has to reflect the purpose of DevOps. And the purpose of DevOps is very simple. We want to deliver more code faster. That's it. Right? It's not complex. We want to deliver more code, change the corporate culture. We have to change the corporate culture, because if you don't change the culture, if you just come in and say, oh, well, we're now doing DevOps, there's Peggy, what happens is that nothing actually changes. And so the automation doesn't really work. Or, oh gosh, we hit a problem, this last deployment failed, so now we're doing everything manually. Or, oh man, the business didn't like the way that we did the last thing, so we're just gonna throw all that stuff out. I mean, and so what happens is that you fail at DevOps. If you don't fundamentally change what you do and how you do it, you completely fail at DevOps. Getting the tools, setting up the automation, it's a bunch of work, don't get me wrong, it's a ton of work, but it's the easy part. It's the simple aspect of DevOps. The hard aspect of DevOps is making that cultural shift, making sure that, for example, DBAs are working out of source control, that they don't go, well, there's the database, I can make changes, it's no big deal. They can't. Everything has to go through source control. Everything is source control. And if it's not in source control, it doesn't exist, right? And that's a cultural shift that's necessary to deliver DevOps. If you can't shift that culture, you can't do DevOps. And you've got to start there. Now, I work for a tool vendor. I work for Redgate Software. I want to sell you lots of product. Absolutely, I do. That's my #1 goal in life, is to make sure that you buy stuff from me so I can pay my mortgage, right? That's my goal. But I want you to be successful. When you implement your DevOps process, you've got to have changed the culture first. If you can't change the culture, you will not succeed. So please, 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 focus first on process, focus first on people, focus first on your culture, and then come and spend money with me, okay? That's the plan. How much time do I have left?
30 seconds.
Awesome, because that's all I needed. My name is Grant Fritchey. I work for Redgate Software, and I very much believe in DevOps, and I want you guys to get on board with it, but change that culture first. That's it.
Excellent.
Thank you.
Thank you. So that was fantastic, and that was Grant. And next up, we're going to have Vicky doing something about bugs, bees, bumblebees, something like this. Have you done the do, my friend?
Yep, I have.
I'm just going to share this to the room so that people in here can see. All right. So I'm Vicky Harp. I'm the PM for the SQL Server tools here at Microsoft. And what I wanted to talk about today was just a little bit of an overview of some of the things that we're looking for in a good bug in GitHub. So I'm going to use our project as an example, but I'm hoping that you'll look at this as something that's a little bit more generically applicable to any of the open source projects that you're looking at. So in Azure Data Studio, oh goodness, I've got a lot of stuff going here on the side. Let's see. Over here in Azure Data Studio, you can see I've got quite a number of bugs that I've opened myself, and I want to show you kind of an example of what one might look like. So here I have, cannot edit markdown cells after saving notebook. So this is one that I opened for my own team, and you can see the main context of it is I have a description of what it is as a bug. After saving the notebook, the markdown cell disappears from the editor, and then I have an animated GIF which shows exactly what it is, and I should do the entire reproduction. And then down below, I have all my version information and all my system information. Now, this seems like a lot to pull together for a bug, so I'm going to show you the basics of it, what you can do for any project, and then how you can do it for something like Azure Data Studio that already has a workflow put together for it. So what I've done is I've actually discovered a bug. I found a bug yesterday, and I decided to hold it for today to open it so that I could show you what I would do. So here's the bug. I'm in the new SQL Server notebooks in Azure Data Studio. And I'm going to go down here, and Azure Data Studio has the ability for you to peek definitions. So if I go to peek definitions or hit F12, go to definition, it should open a new window. So let's give it a second, warm back up here. F12. I'll see there's a bug itself. It's not opening. No, there it goes. So it opened a new definition. It shows the definition of sys databases. But then when I scroll back over here to there, it scrolled back to the top of the window again. So I'm not back on the cell that I did that on. So that's kind of a fuss, right? Nobody really wants to deal with that, especially if you're doing a presentation. So let me hide this. So what I would do is, let me go ahead and close that. I use this application on Windows called Screen to GIF. And what this is an easy little GIF recorder. So I'll do this, and I'll just kind of put the valid part of the screen in here. And it's, you know, important to try to make sure that when you're doing this, you have taken out any personally identifiable information, anything like that. I typically keep my server in a pretty, you know, open, cozy way so I can show people. So on the screen to GIF, again, sizing it. This is the hardest part of the whole process. I put it at 5 frames per second because really we're not looking for a lot of context here. The other trick that I do is if I'm expecting that this is a timing-based thing, I will go over here in Chrome, open a new window, and do stopwatch. So right here built into Google at all times, you have a stopwatch available. And so what I would do is I would start the stopwatch, have it also visible on the screen during the GIF. So that then whenever somebody is seeing it, they don't have to worry about whether the frames per second is accurate for the timing. They can see in the screen what's going on. So just for the sake of it, I'm going to go ahead and pull that in here too so that you can see what I'm talking about. Let's see if I can resize to get both of them in the window. Well, maybe it's not worth it, but so I'll show you the gist of it. So let's say I hit record, hit start. Then if I hit stop, maybe you don't see it in there, but it's actually been recording all of these screens. And then whenever I go into screen to GIF, let's stop. It's going to pop up and it's going to show me all of the frames. So let me, and then in screen to GIF, I would be able to see exactly what the timestamps are for whatever I'm working with. So that's just kind of a handy thing to do. So let's do the real thing and capture the real bug. So I'm going to close this. I'm going to hit record. I'm going to scroll down, select that sys.databases, hit F12, give it the moment. So I should probably open a bug on the fact that it's taking a moment to pop up. And then whenever it pops up, I'm going to go back over to the other screen. And then that completes the problem. So I'll hit stop on that. Discard the previous project, and then I'm going to save this into my bug folder. So save as, and then I keep a little folder by month. Notebooks scrolls to top. So this is just doing this much on any project is a huge help. Getting that little video, that little demonstration of what's going on. So in Azure Data Studio, we also added some capabilities to help people get this done. Can I move this guy? No, okay. Move this guy over here. Down here on the bottom right of Azure Data Studio, we have a smiley face icon. And if I hit there, I have a submit a bug. And then this will help you to get it in the right place in the first place. So one of the really important things to do is to make sure you're putting your bug in the right repo. So one of the things that we have in Azure Data Studio, and which you'll also see, I believe, in VS Code, is the ability to pick what is the bug on. Is it on Azure Data Studio or is it on an extension? If it's on an extension, which extension? And the reason we want to know that is because some of those extensions are going to have their own repos. And so this will help you make a better choice. Well, I'd say so. So it's actually of course I'm live, and so the one thing that I'm demoing is going to flip out on me. Did I mention that this was today's insider build? Actually, I think what it's doing is it's the encoder back here was taking a moment to save the file. So let me reopen Azure Data Studio. So now I've got this file saved, and I'm going to paste in the bug. Well, so I say, with great hope. All right, well, there we go. So I'll pop this in, bring up my smiley face. And whenever you fill out this form, all it does is it pre-populates all of that system information that you might have, and it puts it into those regions for you. So if I put submit a bug here, I'm going to just bypass this here in a second. Yeah, so I'll open a new bug instead. Which one? I can erase it. Yeah, something's going on down there. So bug report. And put a descriptive title. So Azure notebooks scroll back to top after opening in window. As you can see here, we have this thing that tells you anything else that has been, here we go, tabbing away and back to notebook scrolls, loses scroll position. So I actually found a duplicate, and you can see that it has previously been closed. So this is even better because it says, hey, it's been fixed. And then I'm like, this is 2 days ago. I'm using today's build, so that's not correct. So what I can do is hit reopen issue. Say, hey, this is on today's insider build. And then I'll go open my handy dandy screenshot here. I put in my pictures under defects, under March. Then I put my notebook scrolls to top. And you just, GitHub will let you drag it in there. Hit preview. And there we go. So now that's just kind of the general flow of how I open bugs. The main thing I wanted to show here is that ability to do that GIF screen capture, but also it's also important to make sure you're in the right place. Make sure that if it already exists, go ahead and add it to the existing issue rather than making a new one. And when possible, include all your insider, all of your version information. Since this is a reopen and it's today's build, it's not as big a deal. But and then normally on a more stable version, I would say recommend use this little button down here, but it's going to give me a demo fail today on the bug submission, which how do you submit a bug on that? So thank you all very much.
Yes, we would like to share that. Wow, infinity video loops. Hello, thank you, Vicky. I'm bending down because next up is, oh, my knees hurt. It's Rik.
Thanks for that. So I'm having an interesting time because it turns out that Rob's laptop's written and runs on coal, right? So, hi, I'm Rik Hepworth. I'm an Azure MVP, and I'm last. Why am I last? Well, because all the cool kids have done all the work, and now I have to write the documentation. So they're all off for beer, and I'm in an empty room. But wait, I have a cunning plan. Unfortunately, my cunning plan is hidden by the user interface for the for the GoToWebinar. Can I just move that out of the way?
Hit the orange one.
I don't do technology.
And then that you should be able to drag
I can
it
go
away.
back to my. There we go. Okay, thank you.
Welcome.
I love having assistants. Right. Anyway, back to the plot. We've got a plot. We've got special effects and everything. So, welcome to my Visual Studio project, and this is where the team releases all of the stuff that we've been working on. And in here, you can see that I'm in our wiki. Lots and lots of great content in this wiki, honest, really. But down here, I've got a section that says releases. And if I click on one of those pages, what I have here is a set of release documentation, which looks great, right? And it shows me what's been changed in the latest release. And so as we've gone on today, you've seen Terry showing you how pipelines work and you can automate tasks. Vicky's just talked about the importance of putting great bugs in. Great commit messages is also important because what we're doing here is we're looking at the work items that are telling the developers what they need to build. We're looking at the commits that have been done against those work items, and we're pulling all of those commit messages out. So we can automatically build our release notes. How do we do that? Let me show you. So I have a release pipeline, and in my release pipeline, I've got some tasks. So one of the guys that I work with, Richard Fennell, releases a whole bunch of great free Azure DevOps extensions. If you want to find them, just go to the Azure DevOps Marketplace and search for Fennell, and you'll find a load in there. If you want to version files, if you want to run tests, all kinds of interesting stuff. The one that I'm using is this release notes generator. And I simply add the task to my pipeline down here, and then I get some settings across on the right-hand side. So I can say, what do I want to generate my release notes into? So I'm going to write out a markdown file. And where's my template that I'm going to use to generate those notes? Over here is my template. and it's Markdown. It's really, really simple. And you can see that what I've got in here is a bunch of variables that are going to look at the REST API of Azure DevOps and pull information back about my artifacts, my builds, and give me clickable links. Now, that bit is a little tricky, and you may find that you need to go to this page, which is the Get Started Azure DevOps Service REST API reference. You might have to look at a bit of JSON and fiddle with your object model, but once you get it working, it's really, really cool. So what I'm doing now, that release notes extension is going to go and look at the environment that we've just deployed to, see what build we've just released, look at the previous build that got dropped into that environment and find the differences and spin through and generate all of that into a Markdown file for me. That's great, but I've got a Markdown file. How do I get it in the wiki? Aha, enter stage left, another extension. You'll never guess who wrote this one. So, having generated my Markdown file, written it out, I now have a second extension, and I say, right, okay, I want to create a new page in a folder called Releases. Top tip, you can create folders using this, but you need to create a page in the wiki called Releases first, otherwise they won't show up in the hierarchy. And what this extension is going to do is it's going to pull down the Git repo that holds the wiki. It's going to put that new page in there, do a commit, and push. And the end result is I get a really great set of release notes, which tells me where are my release artifacts, and I can click and go and find those. What work have we done? What backlog items here did we do? And what commits and check-ins are associated with that? And that means that I'm now finished with my documentation, and I can probably catch up with the guys and go and get a beer before they've got too far down the corridor. How long have I got left?
60 seconds.
Oh, fantastic. If you want to know anything more, I'm Rik Hepworth on Twitter, and you can find my blog at blogs.blockmarble.co.uk, and you can also find Richard Fennell's blog on there and use his extensions. Thanks very much.
Oh, we're getting kicked out. Thanks.
Alrighty. Well, thank you most of all to our MVPs who came along and spoke today for us, and Vicky for hosting us. Oh, I will look at the camera. Yeah, please join us next month. We've got another session up, which will go up on the website. And have a good rest of your day. Bye.
Quick.
Clear?